get started. And before I turn it over to Geoff, I just want to give a reminder that you can find information about upcoming webinars on our website. That's thirdsunsolar.com. And you can also find links to past events or search on YouTube to find any past events that you might be interested in watching. And Geoff is here today to, as you know, he is the president and co-founder of Third Sun, but he's also a residential solar homeowner who is just adjusting to life with Tesla Powerwall, and that is what he's here to talk with us about today. So I will go ahead and turn it over to Geoff.
Thanks, Caitlin. Hi, everybody. Welcome to Third Sun's weekly webinars. We do these every Thursday at 11 Eastern, so tune in, register for these if they're interesting to you. We did a webinar several weeks ago about off-grid and resiliency and got a lot of positive feedback, but also a lot of questions. People wanted to know about what it was like to live with a Tesla Powerwall, specific things about whether or not I could really support a household during a power outage. And I wanted to do a little bit of experimentation myself. So that's what today's webinar is all about. So let's see here if I can press the right buttons. And bam. Okay, great. So there's my system, and the agenda for today, do a quick overview about what makes us an expert and why you should, at least pay attention to our knowledge here. I'm not just making claims or reading stuff off of a technical sheet from the manufacturer. Talk about the storage in general, and then get into the meat of the webinar, the case study. Hooper Ridge is where I live, and so it's what we call our house. Get into some data analysis. I'm a self-professed nerd, geek, call me what you will, but we'll get into the data, and then give the stunning conclusion about solar. Stay tuned for that. And then we'll be opening it up for Q&A. I believe that everyone's on mute right now, but there's a chat function where you should be able to put in Q&A. And then Caitlin, if people are streaming this live on Facebook, how can they get their questions to you for the Q&A?
Yeah, I'm working to get it up on Facebook right now. It's going a little bit slower than I'd like, but they can just submit questions into any comment box where this ends up getting uploaded, and we'll be sure to answer them.
Super. All right. Well, we'll just jump right into this, and hopefully Facebook Live will catch up with us. So Third Sun Solar, there's our building. We've been doing this for 20 years. This is our 20th anniversary year. We're very excited to celebrate that. So we've been doing this for residential, for commercial, for municipals, for government agencies. We're happy to do it for anybody that wants to go solar. And this is one of our larger projects that includes carports. And we were ranked by a magazine and a kind of competitive analysis as the #1 installer in Ohio. We do agriculture, we do large buildings, small buildings, and everything in between. We are a B corporation where, like Patagonia and Cliff Bars, we are actually third-party reviewed for our commitment to people, planet, and obviously profit. We're a business. Without further ado, we'll talk about storage. So the primary reason people are interested in storage is for grid outages. They want to have power during backup. And so we've helped, dozens of homeowners and a couple businesses with this, and it's more and more interest as reliability of the economy, reliability of the utility grid, and just that security and safety of knowing that no matter what happens, you'll be able to power your critical home infrastructure, your own power system. We are retrofitting batteries to our past customers in many cases, as well as starting fresh with a lot of customers. It's not quite half, but I think year to date this year, we've got about a quarter of our customers are putting in systems with batteries. So that's a big change from the past where about 99% of our customers were doing pure net metered systems without batteries. So one of the cool things about solar is about Tesla is it's got this cool phone app, and one of the features of the technology is even when you're net metering and you're still working with the grid, you can set up the system to do what they call self-consumption mode. And so instead of powering the grid when you're not home to use your power during the day, you can actually put the power into your battery. And then at nighttime, instead of buying the power from the grid, which is what most battery-free systems do, you can actually consume your solar power out of your battery. There's a lot of set points on it, but it's pretty cool. You can also set up these systems to do time of use mode. Not every utility offers a time of use tariff, but within Ohio, some of our utilities actually will charge different rates for different times of day. During the daytime, they have different costs, and so they pass that along to the consumer, and that lines up well with solar. So again, you can use a battery to maximize your economic payback from time of use tariffs. This isn't exactly what my system used to look like. It's actually kind of embarrassing. I think I'll probably dig up some old photos from the system that we put in, but it was not as clean as the systems that our professionals install for people. I was an amateur when I started, and I did my own system, and it was a little bit home built, we can call it that. In any case, to give you a perspective, I had 9 of these batteries in my system. I think this table shows 12 over there. But effectively, I had about a 10.8 kilowatt hours of lead acid batteries. And with lead acid, you can only use 50% of the battery rated capacity for your day-to-day use. So effectively, I had about 5.5 kilowatt hours of power. And we ran our house like that for 19 years. Today, I have a single Tesla wall pack, Powerwall, rated at 13.5 kilowatt hours. And so we're installing these in singles, doubles, triples, quadruples. We can stack, I think, up to 8 of them if we need to. I think we've installed primarily doubles and triples for people. And again, every household's different. Our systems are custom designed, and our solar consultants can walk you through the options and size of system based on what your specific home needs are. All right, so the case study. So there's our house. You can see up there on the rooftop, we've got about 7 kW of solar. When we first started, we had about 500 watts of solar, or half a kW. But as we expanded our usage and had kids, went from a propane refrigerator to an electric refrigerator, got a hot water, a clothes washer, etc. Had kids that watched TV and played video games. Our usage went up and we expanded. And so our current system is sized at 7 kW, and that powers our home as well as an electric car. So there's my system right now. And so I'll walk you through the components. The Powerwall is the large white unit there that says Tesla on it, and that's a single Powerwall. And then this lower unit here is called the gateway, and that's also a component from Tesla. And that's what senses the utility power, senses the solar power, and then it controls the battery in terms of where the power goes. It also has an antenna where it talks to the Wi-Fi and can send signals to and from the cloud, and I can check on my phone how my system is doing. I can see if there's a power outage. I can control and adjust my system from across the country or around the world if I need to. It's pretty neat. Then this item here on the right is my inverter for my solar system. So again, the solar modules on my rooftop are DC power. That 7 kWs DC comes down and it gets conditioned by this solar inverter. And before I had the Tesla, that inverter simply put power out into my breaker panel or my load center. And if the power went out, the solar modules shut off for safety. So a normal system with no battery works side by side with the utility power, and it's net metering. And when the sun's shining, it's making power and mixing with the utility. At nighttime, you're getting all your power from the utility. And during a power outage, the solar system shuts off for safety. Without batteries, during a power outage, a typical solar system turns itself off. Now that we added the gateway and the Tesla Powerwall, we now have the ability to run off-grid during power outages. And that's what my experiment's all about. So these two load centers are different. The first one is what I call my main load center, and that's attached to the utility grid, and that's attached to the Powerwall, and that powers my electric hot water and my geothermal heating and cooling system. The smaller one is what I call my critical load sub-panel. And so that is where I have all my plug loads, my lighting, my garage door opener, my refrigerator, all the other loads in my household that are powered by the Tesla during a power outage. So we'll talk a little bit more about that in a little bit. All right. So again, my house is not your average house. It's hyper efficient. It's super small loads. Everything is LED. Everything is the most efficient possible. And again, my EV charger, my electric hot water, and my geothermal are not backed up. So that allows me to power everything with a single Powerwall. When you contact us and work with one of our solar consultants, we're going to look at your utility loads and work with you and say, okay, if you want to power everything, you might need 4 Powerwalls. If you want to break your loads into a backup power critical load center that are backed up and some that are not backed up, maybe we'll use 2 Powerwalls or 3 or a single. A lot of options. And that's what our experts do, is they kind of walk you through your choices and work with you and your budget and your goals to find out exactly what you are going to end up with. All right. So again, I talk about our system being very small. So here's the data that I've gathered for the month of April, where I was tied into the utility. And then for the last 2 weeks, so it's for part of April and for May, 14 days or 11 days actually of off-grid. So my average home usage before I did the experiment was averaging 15.58 kilowatt hours per day, or 467 kilowatt hours per month. And that is with my heating and cooling. I did have some heating going on during that time period. It was some pretty chilly days in April. And then my average solar production per day was 11.7 kWh per day. And that averaged out to about 353 kWh per month. Then after I disconnected from the grid and ran in an island mode, the average usage without the heating and cooling and without the hot water was 2.46 kWh per day. And that would equate to about 74 kWh per month. That electric bill might be $10 a month. So as you can see, I'm a hyper efficient case. We don't have kids or teenagers watching TV all day. My wife and I work here in town at the office. And so without the heating and cooling load, this is just my refrigerator, which is super efficient, and just some background phantom loads, and then lights and computer usage, audio visual, stereo at nighttime. But it's pretty low usage. Everyone's different. And then my solar went way down to 3.21 kWh per day in my off-grid mode. Why is that? Did the sun go away? No. So we'll get to that in a minute. That's one of my big conclusions. Big difference between an average of 11.7 and 3.2 on my on-grid and my off-grid. So we'll talk about that in a minute. Stay tuned. All right. I said I'm a data nerd. So one of the coolest things about the Tesla is the app. And so on the right there is a display of a typical one-day report for what actually happened. And I'm going to go through that blow by blow. But let's just check on my Tesla right now. So right now you can see it's got an orange box around it, and it says backup mode. So that means that I am currently not connected to the utility. It's telling me there's an outage, even though I faked the outage just for this experiment. And right now my Powerwall is at 96%, that's down there. And that means that I'm almost full, just about 100%. And right now, it looks like the house is being powered from the Powerwall. There's no solar going into the house, and the grid has an X through it. That means that there's an outage. And right now, my house is consuming 0.1 kW or 100. So again, probably some of the background electricity. Probably the fridge is not pulling power right now. I don't think I left any lights on, so that might be just the plug loads. Some of those power cubes on my walls. I leave a lot of things turned on so that the clocks don't flash. So those are phantom loads, just consuming power all day long. Again, it's kind of fun. And so I can press this button here, say my energy use, and then that shows me so far, actually that was a couple of days ago, I can scroll through it. And so yesterday, that's what I did yesterday. And that's what it is from midnight until right now. So it's kind of cool for a nerdy person like me to check on my system, even though I'm sitting here supposedly working at the business. So one of the first features of this thing is the home usage. And so it tells you, okay, on April 6th, my house used 7.9 kilowatt hours. And then you can see these spikes. The peak of that spike there is probably my compressor for my geothermal system, pulling almost 6,000 watts. But it doesn't do that continuously, it goes up and down. On April 6th, it was a pretty good solar day. I produced 16.9 kilowatt hours. And you can see, as you would imagine, the sun rose and was low in the horizon, came up. You can see the little zigs and zags there, the jagged piece. That's probably a cloud moving across the sky. It peaked around 1 o'clock and then started to go down as the sun started to go across the sky. And then the sun set. I was still getting a little bit of power at 7:30, but not very much. So then this shows the performance of my Powerwall throughout that day. So the total that I drew from my Powerwall was 2.9 kWh. It doesn't show up, but I can scroll down and it shows how much went to the Powerwall also on that day. But as you can see, it actually started charging the Powerwall. I left this to have a 50% of the Powerwall being used to go in and out in self-consumption mode. some people leave the Powerwall set to 100% backup, and it doesn't really go in and out. It just stays filled, ready for a power outage. I've got my Powerwall set up for 50% self-consumption mode. So that means it always keeps 50% of its power as backup should the grid go down, and lets me use the other 50% to go in and out. And so I charge my Powerwall with the solar power during the day, and at around noon it peaked, and it had no more room to charge because I only have one Powerwall. Then at night, I started discharging power into the afternoon, and that's just kind of how my settings work. And then here's the grid. This is back when I was not off grid, so I had the utility, and I was able to pull power from the grid while my utility or my geothermal was cycling. And then you can see I was exporting, even while I was filling my power, about half the power was going to the Powerwall, and half the power was getting exported into the grid, powering the neighbors, and spinning the meter backwards so I have a credit. And then you can see here at about 1 o'clock, I was still generating a lot of solar. I wasn't using the power in the house, and the battery was full. So the rest of the power started going out to the grid during this period of time here. And then at nighttime, I stopped exporting, and I didn't import anything either. During this evening of that day, you can see that my loads were being powered from my battery. So that's what the self-consumption mode is. I'm using power at 8:30. The power is coming from my battery. It was stored there during the day, and I'm not pulling any power in from the grid. All right, so that's the normal way my system is set up to work. And again, this is the synopsis chart with all 4 channels: the home channel, the solar channel, the battery in and out channel, and the grid in and out channel, showing kind of what it all looks like. And if you look at that for the first time, your eyes kind of get cross-eyed and you get confused. But just like with anything else, over time you get used to it, and you'll be able to see, oh, I see exactly what's going on. It's a diagnostic, it's a status update, and it tells me some interesting information, so I kind of manage my home power use. And at that time, when I snapshotted this, my battery was at 92%, and it was discharging into my house. That day I was 77% self-powered. All right, now here's my experiment and the conclusion. So what I did was I tracked it from April through yesterday. And so the 3 pieces of data here, the blue is my home energy used. And you can see that I had my geothermal heating on, and there's some cold snaps at the beginning of April. Then it was pretty warm, and I didn't have very much heating loads for that week. And then the heat still started to draw power, and then it tapered off. And then on 4/21 is when I turned the breaker to simulate an off-grid experiment. And my usage went way down because I didn't have any geothermal or electric hot water working then. The other thing this graph shows is my solar production. So it goes up and down depending on the clouds. Obviously, April 2nd or April 1st was a pretty cloudy day, then some good production. And then another cloudy period around the 13th, then it goes up, goes down on the 17th, and goes up. And then you can see when I did my experiment, the solar seemed to really go down. The sun didn't go away. So I'll tell you in a little bit what happened. You can see then that the green bars are exported to the grid. So you can see that I was making solar, making my power for my house, and exporting power to the grid through all those days. And then when I clicked the breaker, I was not able to export power to the grid anymore. So here's a previous snapshot that we talked about that showed a typical day long, a day in the life of my house system back on April 6th. Here's that same report from May 4th, from a couple of days ago. So what you can see here on May 4th is I've got my battery powering some loads. I've got my house going up and down and the battery is there powering those loads. The sun comes up at around 8 in the morning and starts to go up, up, up. I'm not using much power, but my battery is there to soak up the power. And it soaked up as much power as it had availability for. And then it was full. It had nowhere for the sun to go. I wasn't at home to use power. And so my system automatically shut off the solar. I didn't have the grid to send it to. I didn't have any usage going on at home, and the battery is full. So basically, on May 4th, I gave up all afternoon worth of power that I could have been using. And then at some point in the evening, my usage had used up enough power that there was room in the battery, and I started absorbing some solar that was being generated, and then I started discharging power, powering my home at nighttime. So here's a little bit of a synopsis. During the home, during the on-grid experiment, the average was 15.58 usage per day. The usage dropped off to 2.4. The solar averaged 11.7 per day, and then it averaged 3.2 because of what I'm going to call solar clipping. Basically, when there's nowhere for the solar to go, I lose my solar, it's clipped. So the average power from the battery during the normal usage was 5.3. That got cut down to 3.7. The energy sent to the battery averaged 6.2. That got cut by 4.5. And then my average from the grid was 12.9, and to the grid was 11.5. And when my off-grid was going on, there's none of that. So now I'll open it up for a Q&A. I think I saw a couple of chats came in. And again, if you are live streaming, Caitlin will give you some guidance as to how to submit questions. And if you're on the Zoom, you can use the chat feature to submit questions.
Yeah, thanks so much, Geoff. Unfortunately, we were never able to get the Facebook live stream to work, but if you are watching this in the future, you are welcome to post questions that you have. And folks that are here are also welcome to ask questions. I've got a few of my own, but I see that a couple have come in. So the first question we have, you mentioned being able to set up the reserve capacity at 50%. Can you set the time of day when the remaining 50% can be used? For example, only use the Powerwall between 10 p.m. and 4 a.m.
Yeah, so two questions there. So the first one is how much of the Powerwall to dedicate to backup power and how much of the Powerwall to dedicate to the self-consumption mode. And so I chose 50% somewhat arbitrarily. Some of our clients actually, their primary goal is to have power during a power outage, and they want to leave their Powerwall at 100%. And so that's just in the app. You can slide it up and down. It's a Tesla product, and like all Tesla products, it's very user intuitive. And so you can set it at 78% or 21% or 50-50 or 100%. So I just chose 50%. I'm not sure if I'm going to leave it set there or not. And then the second piece is time of use. Yes, you can set up your time of use. I'm not using the time of use feature at all. But let me pull it up here and we can just show you what it looks like. So it's here in the app, customize, those are the options, self-powered, and then storm watch. Oh, that's another cool thing that the Tesla does, is you can turn that on and off. And if you have it on, I've got mine set on, even if you have time of use or self-consumption on, if the storm watch gets a signal from NOAA, the federal weather stations, if they are saying, hey, there's going to be high winds coming into your area in the future, I'm not sure if it's 48 hours or 24 hours, but if a high wind alert comes through that might take down utility infrastructure, the storm watch will basically override my self-consumption mode and start charging the battery back up to 100%. So I've got 100% of my fuel reserves set up for off-grid, because we've had ice storms here in Ohio where, depending on where you are, it might have been almost a month, 14 days, 11 days before crews got power restored. In urban areas, people usually get their power restored a lot faster. Back to the question here, advanced time-based control. So if I turn that on, then it goes to cost savings, and it allows me to set up the actual windows. I think I've got, maybe it's easier to see on here. Set up the actual windows for when the time of use is used. There it is. So you can see here, you can use these slider bars to go exactly what time of day you are discharging, what time of day you're absorbing, and what time of day you're in backup mode. I hope that answered your question.
So Kevin also has a follow-up question, and Kevin, let me know if I get this wrong. I think I understand it. So you are wondering if it's better to have the added battery capacity to store energy, or to send it back to the grid for net metering, which is a better option. Would you be able to address that, Geoff?
Yeah, I think the only way to answer that question is, what do you want? So if you're wanting maximized economics, then currently in Ohio, probably best to send that power back to the grid and have a smaller battery. If you want backup power, and you want to have your laptop, your lights, your refrigerator, your freezer powered, then we can size the battery based on how many days you want to be able to run during the winter, how many days you want to be run during the summer. So the batteries are not cheap. Our typical system might be $14,000 to $28,000. So the time of use mode and the self-consumption mode don't economically in Ohio today pay for that. In Hawaii and in some parts of California, I believe, sometimes the time of use rates can really improve your economic payback and start to justify the battery as an economic reason. We see those rates coming to the rest of the country over time as the smart grid comes in and the utility tariffs continue to move towards more of an Internet of Things kind of a relationship. But today in Ohio, the economics don't justify the battery as an economic only. Most of our customers are doing it because they want that backup power and that resiliency. And then they've got that ability to do the time of use just to sweeten the economics a little bit.
Yeah, great. Kevin says, thanks for the answer. And it does seem to depend on the customer's wants and goals, and that is true. So another question we have come in. Hi, Jerry. We have a solar customer with us. So he has a backup gas generator, and he's wondering about his situation. Is it redundant on, I assume you mean on top of the gas generator, to also get a Tesla battery?
So yes, a lot of our customers, and we sell generators. We're a authorized, trained Kohler installer. A lot of our customers want backup power, and they would like to have enough power to power electric heat, or a large HVAC system, or even their air conditioning. And so powering air conditioning and heat is a pretty large load, and a Tesla can do it, but the solar that recharges the Tesla, if you have your power outage in the winter and it's during an ice storm, it's very unlikely that we're going to have a lot of solar in the months of January, especially during an ice storm. So you could have a very super fine Tesla battery backup system, and you could have a power outage in January, and that system could last for several weeks, just powering your lights and your plug loads and your refrigerator and your internet. But if you wanted to power your heating and cooling system, it probably would discharge very quickly and wouldn't give you very many days of autonomy. For that application, we would probably recommend a backup power system with a generator. So each case is different, each customer is different, but a generator has basically unlimited power whether the sun's shining or not, with the only limitation being that you have to have fuel. Most of our generators, we use natural gas or propane, so we don't have to worry about filling up a fuel tank with messy, toxic fuel. And again, it depends on what scenario you're planning for. We do have customers that want to have that peace of mind for resilience, that even during some kind of a national emergency, maybe there's not even fuel available, they still have the backup power from their Tesla and the backup power from the sun, which is not going away, as their primary source. And some of them have generators too. So we've got hybrid systems with Teslas and generators and solar.
Awesome, thanks, Geoff. And at this point, we don't have any other additional questions, and we can wait a little bit to see if any trickle in. One question that we hear a lot from folks that give us a call interested to talk about batteries, and Geoff, you might have covered this as I was trying to figure out the Facebook ties, but we get a lot of calls from folks who are eager to break ties with their utility company. Is this necessary, or what would you say to someone who is really interested in Powerwall and also breaking those ties?
Yes, you can do it, but your solar is probably going to need to be larger than a system would have to be if you still had the utility power there. So I can say that in a different way, and I'll go ahead and go to my the graph that kind of sums it up. This one on the right here is my off-grid system. So this is if a customer that wanted to disconnect from the utility, this is kind of a scenario they would have, and they would be able to charge their Tesla up with their solar, and then their solar would be doing nothing. They'd be living without solar during the afternoon, and then they'd be using power in the evening. Whereas this one on the left is my system with utility as effectively a huge battery. That's the way I think of the utility at my house. My house is net zero, so I make all of my power from the solar. A lot of that power is made in the summer, and I send it to the utility and spin my meter backwards. And then in January and February, two things happen. I've got less solar, there's more clouds, and the sun is up in the air for a shorter period of time. and I have higher home loads. I'm actually using geothermal heat to heat my house. And so I'm actually in the winter months, I'm borrowing power from the utility. And in the summer months, I'm sending it to the utility. So I'm kind of using the utility as a big battery. That's an interdependent system. That's the way most of our systems work that our customers choose. But because the technology for the batteries has gotten so far, so reliable, and the costs have come down, some customers are, budgeting for and buying a very large system, putting in 4 Powerwalls, a large solar array. These systems are more than $100,000. But if someone's building a $500,000 house, to make it a $600,000 house with its own power system is a good investment in some people's eyes. A lot of those same customers also have a backup generator for redundancy, because again, without the utility power there, your battery can be full. You can have solar power going into it, but if there's a long stretch of winter weather with no sun in Ohio, which is typical, you're still going to want to have that generator. So we do service a lot of off-grid, truly off-grid customers that do not have the utility to their house. And I can't think of one that hasn't installed a generator. It's our strong recommendation that even if they never plan on using it, that they add a couple $1,000s and we include the generator in the project just to have that redundancy.
Great. An additional question here regarding other battery manufacturers. Do other battery manufacturers have similar apps that allow customizing and monitoring like the Powerwall?
That's a good question. I'm up to my neck in the Tesla Powerwall for a variety of reasons. I chose it for my house as the tech I was going to go to replace my old lead acid batteries. So some of the off-grid inverters or the battery-based inverters have their own apps. So there's one from SolarEdge, and so there's a system that we install using the LG Chem lithium-ion battery paired with a SolarEdge inverter, the one that uses the battery. It's called the StoreEdge. And that has an app where you can see what's going in and out of the battery, and you can see what your solar system is producing. And if you pay, I think, an extra $350, you can have consumption monitoring added, and you can see what's going in and out of your house as well. So I don't have that app up. I should probably get into it. One of our solar consultants has dug into that very well and has an example, app on their phone and probably could answer those questions better. Maybe we'll do a seminar where we have a side-by-side feature set for the different brands that are out there.
Great. And a different question, what other battery brands have gateway type devices?
Yeah, so that interface with the utility is critical. It's a safety feature, and the utility will not allow any solar systems to hook up to their system unless they have that safety feature that senses, hey, the utility's on, everything's normal, it's good, so I can buy and sell, I can export and import, I can net meter. And then if the utility goes down, it breaks the connection with the utility and allows the house to operate in island mode or off-grid mode. So all of them have one or another type of interface with the utility. In the Tesla system, it's called the gateway. In the LG Chem StoreEdge system, it's integrated into the StoreEdge inverter.
Great. I don't see any other additional questions coming in, but I do want to remind folks, both on this live stream as well as those of you watching this in the future, that we do have a lot of similar content on our YouTube channel. If you're interested in learning more about net metering, more about batteries, more about just Solar 101. We've got some great video content up there from Geoff and from some of our other solar consultants, so you can kind of see them, get a feel for what they're like, and get an understanding of solar a little bit better. Information is a powerful tool. So thanks so much for sharing with us, Geoff. And we don't have any additional questions, but expect an email from me with a copy of this webinar, as well as a survey. We'd like to bring you content that you would like to see in the future. So we'd appreciate your feedback, so we can bring you more of the stuff that you would like. And with that, we will go ahead and end the meeting. Thanks so much, everyone, for attending.
Thank you, Caitlin. Thanks, everybody, for your interest. And as you can see, I played around with the Zoom virtual background and put this up on my wall behind me. I just love solar. I love technology, and now I love my Tesla. I've got a Tesla in my garage. It's a lot of fun.
All right. Bye-bye, everyone.